So, good night, everyone. It's a pleasure to welcome all of you to this highly anticipated webinar titled Petroleum System of Iraq. My name is Rzgar Sola. I'm a president of SPE student chapter. On behalf of our chapter, I would like to extend my gratitude to each of you for taking the time to join us today. As you know, Iraq stands as one of the world's most prominent oil-producing nations, holding immense geological significance with its rich petroleum system and vast reservoir. This webinar aims to delve deeper into the unique geological feature of Iraq, its key reservoir, and its pivotal role in the global energy landscape. We will also explore the challenges and future potential of the oil and gas sector in this region. I'm honored to introduce our distinguished speaker for today, Dr. Rzgar Abdula, an expert in this field with extensive knowledge and experience in the geology and petroleum system of Iraq. Dr. Abdullah's insights will not only deepen our understanding of Iraq's energy resource, but also inspire to think critically about the future of exploration and production in this vital sector. To know more about the background of dear Dr. Rzgar Abdullah, he is an associate professor in the Soran University, Faculty of Science, Department of Petroleum Geoscience. He is holding Bachelor of Science in Geology, Salahuddin University, in 1987, and also Master of Science in Geology, Colorado School of Mines, USA, 2010, and Education Doctor of Philosophy in General in Geology and Petroleum Geology, Soran University, 2018, and also his participation in the social organization. He is member of International Union of Conservation of Nature, member of World Commission and Protected Areas, and member of AAPG, Association of Petroleum Geology, member of American Ceramic Society, member of Iraqi Geologists Union, founder of Kurdistan Geological Society, member of Kurdistan Geology Syndicate, and also member, founder, and head of Iraqi Society of Petroleum Geologists, and member, founder, and head of Kurdistan Geopark Association. Before we proceed, I would like to remind everyone that this session is being conducted live via Google Meet. Please ensure your microphone and your video cameras remain turned off during this presentation to avoid disruption. And feel free to drop your question in the chat box. We will address them during question and answering session at the end of the presentation. Once again, thank you for all of you for being here today. Let's make the most of this incredible learning opportunity. Without further ado, please join me in giving a warm welcome to Dr. Rzgar Abdullah. Dr. Rzgar, if you're ready, please share your screen with us. Dr. Abdullah.
Okay. Thank you very much, Rzgar, for your introducing me to attend this. So I don't know what language you prefer I speak today.
Dr. Rzgar, it depends. The most ones we want, actually, it's English. But if you want to add something in Kurdish, it's also okay for us.
Okay, sounds good.
Okay.
Okay. Let me start our webinar today. First thing, I will explain what's the system. Very often we hear a lot of things linked to system like political system, economic system, and etc. So the system, it consists of several elements. Like, let me bring an example, like power system. So we have to have the station that produces electricity, and we have a line or cables to transfer power from the station to local station and then to the houses, and from the houses we have equipment that work with the power, and then we have to switch to turn on off. So as you see we have sequence of elements. All of them should be there. In one of them missing, the system doesn't work. And when we turn on the switch, so this one we call critical time. So in this time, all elements should be there. If anyone missing, like a bulb, if not there, we don't see any light in our house. For petroleum, same thing. We have petroleum system. The main element is for making petroleum system. It's like source rock, reservoir rock, cap rock, or we call seal rock, and we should have traps. And besides this, we should have some kind of process like generation, migration, and accumulation, and then preservation. When we talk about petroleum source rocks, what do we mean by petroleum source rock? Any rock that contain more than 1% or more, we call source rock. Usually source rocks are shale, carbonate, or marl. Most likely in our area, we have the main source rocks in our area that consist of carbonate and shale. Rarely we have marl one, and in western part of the world, we have mostly shale. Rarely you hear that carbonate become a source rock in western part of the world, like United States and Canada and Latin American. So we have different source rocks in Iraq throughout the geological history. From oldest to youngest, we can recognize them, and probably you have an idea about them. Then what else we have to know about source rocks? Source rocks which contain 1% 1% total organic carbon or organic matter. They come in different types and quality. For example, if you look to vegetables or plants, we see that we have algae, we have trees, and each part of trees, for example, we have roots, we call subelinide, we have leaves, we call cutinide, and sporinide, we have pollens, veterinide, and we have also some kind of organisms like fungi that not produce any hydrocarbon or petroleum, we call inertinide. So mostly from humanide or other types of organic matter, when degrade, becomes inertinide, or we call in general, we call type 4 kerogen. So type 4 kerogen, most likely it's inertinide, inert, does not produce any petroleum at all. Rarely some gas that would be not accountable.
Doctor, sorry for interrupting, but did you share your screen?
No, just I am.
Giving introduction.
Not started with my presentation slides. Yes.
Okay, Victor. Okay, go ahead, please.
Just to remind you, probably you got this kind of information throughout your bachelor degree, but you forgot, probably some of you has been graduated for several years, right? Like we said, we have different types of kerogen, type 1, type 2, type 3, and type 4. Type 1 produces oil, type 2 produces oil and gas, and type 3 produces gas, but probably in some cases a little bit oil as well, fluid. Reservoir rocks, also a type of rocks that has porous, so should have porosity. In addition, these pores should be connected to each other to become like a channel to transport or to move liquid or gas through channels. We call permeability. The permeability for moving gas it should be better media for transporting, because gas doesn't need that much permeability like fluid. And the types of rocks that become reservoir rock are sandstone, or in Middle East in general, carbonates become reservoir rock as well due to secondary porosity that comes from tectonic activity basically, or from other diagenesis processes like dissolving some kind of minerals or fossils, or the cleavages or joints that occur due to tectonic stress. Cap rocks, or in some cases we call seal rock, should be impermeable, no porous, and usually they are consist of evaporite, like gypsum, anhydrite, halite, or shell or claystone. In a lot of cases, become cap rock. And traps, as you know, we have two main different types of traps. They are stratigraphic and structural traps. The examples of structural traps like anticline, fault, and for stratigraphic, like we have pinch out, or we have some kind of fold mix to bring some kind of rocks that's not porous, parallel to some, to adjacent to some type of rocks that has porosity like sandstone. So the lithological differences become like barrier for stopping petroleum from movement, or from migration from one location to another location. Let me share this. Let me start with tectonic map of Iraq. As you see here, we have different tectonic zones in Iraq. Like here, we have thrust fault. And here we have northern thrust zone, which is located in like starting from Zakho to Kanimasi, and then we have here from Qal'adza to Pianjin, and then we have high folded zone, low folded zone. as you see, and then we have Mesopotamian basin, and we have Western desert, which has two subzones, Rutba Jazeera and Salman zone. We have here Salman zone as well, and what controls the Iraq are some basement faults, as you see here. As you see here, we have some longitudinal faults, and we have some strike slip faults. So the main one here in our area, it is Great Zab River fault, and some others like starts from Ana to Qal'a Dizza. It's also those faults are playing as a conduit or the passage for migration a lot of times, and they make instability for the area, and sometimes they are reason for having seepage or oil seeps on the surface. As you see from a lot of places, we have oil seeps that are occurred due to breaking cap rock. So the cracks occur on cap rocks, then petroleum migrates to the surface. In this case, we call tertiary migration. And as you see from geological map here, we have different types of formations that occur on the surface in Iraq, especially in northern part of Iraq and western part of Iraq. A lot of old formations are outcropping on the surface, but in a Mesopotamian zone and Salman zone, or even foothill zones, not many formations are outcropping. So starting from here, Paleozoic formations are outcropping, and then Triassic formations, Jurassic formations in a high folded zone, and Cretaceous as well on the limb of outcrops, and in subsurface in the foothill zone we have tertiary on the surface, or Neogene and Neogene formations on the surface. That's why most of our hydrocarbons in the northern part of Iraq are occurring in Cretaceous and Paleogene carbonate reservoirs, and in western of Iraq we have a lot of Paleozoic petroleum system, as I'm going to give you some details in the following slides. The main concept that we should understand before we start explaining any petroleum system and processes, we should understand geothermal gradient. Geothermal gradient, it's changing temperature to the respect of the depth. So as much as we go to the down or underground, the temperature increases, but this increase in temperature, it's not exactly the same throughout the region. In some areas are very steep, and some others are not. The main source of the heat is the mantle. It's coming from the mantle. So some areas like Western Desert, when we have sedimentary sequence is like 5 kilometers, so the geothermal gradient there, it's much higher than in the Mesopotamian basin or in the foothill zone. The highest temperature we get in the foothill zone, it's 29 Celsius in Taktak, Shuashok, and almost 28 and a half in western side of the Tigris River in the Mosul area. A lot of and other reasons are like the type of rocks that making the sedimentary sequence in the area. Like some of them has a very high thermal conductivity, some others don't have that much thermal conductivity. So they're letting heat flow become faster in some locations and slower in some other locations. So generally, the heat, it's like 21, 22 Celsius per kilometer in Iraq in general, but in western part, probably around 40 Celsius degree per kilometer. Become 40 Celsius degree. Why? Because it's very close to basement and heat coming from some formations like Akas formation, which is producing heat. It contains a lot of radioactive elements. If you have any question, you can ask me now before I start with each single petroleum system in the geological column in Iraq. Do you have any question? No, I don't hear. Are you with me? Let me see.
Yeah, doctor, but I think they don't have any questions. So if they have,
I thought that I'm lost again. So that's why I'm double checking. You know.
No, doctor, we are with you.
And explaining on one screen and another screen in another. Okay.
Yes.
You say Paleozoic. Paleozoic, it's in northern part of Iraq, in like.
Doctor, yes. Please click on the full screen.
On what?
On the
full
yeah. Okay, doctor, go ahead.
Okay. So Paleozoic, it starts in our area. What we recognize it so far, it starts with Khapur quartzite, Khapur shell quartzite formation in our area, but probably in western Iraq they recognize it Burj formation under Khapur formation from seismic lines, which is older than Khapur, and in probably under Khapur quartzite in Kurdistan should be Sak formation. Sak formation, which is occur in Turkey. It's same sequence, so probably extend this to our region as well. So anyhow, let me recognize some main source rocks, Paleozoic source rocks. Ordovician shells within Khapur formation is considered as a source rock. The basal shell of the Akas formation This Akas formation, it has equivalent in Northern Africa, in Saudi Arabia, in Syria, but it's not It's not existing in Kurdistan region due to erosion, uplift and erosion during that time. So during Lower Devonian, our area is uplifted, and all Silurian sediments are eroded. That's why does not occur in our area, but in western part of Iraq, Silurian units are occurring, which is equivalent to Qusayba hard shell of Saudi Arabia and Batra formation of Jordan. And Khapur has equivalent in Jordan, which is treble formation. As we have also Ora formation, which is very good source rock, and even within the Chazeri, which is almost equivalent to Khuf, not totally. In some parts are equivalent to Khuf formation in Saudi Arabia. So the shale part of the Chazeri formation is considered the source rock as well. This is maturity map of the source rocks. So here in our area, it's almost Silurian are missing, but in eastern part it's over mature, and here the green one, it's mid to late mature, and the yellow one, it's gas window. So most likely we can find oil and gas in western part of Iraq and within the Euphrates subzone, within the Mesopotamian zone, we can look, search for gas or oil, especially gas in that area due to maturity level of organic matter. Reservoir and seals. The reservoir, Paleozoic reservoirs has low quality or low reservoir properties. Based on Jordanian side we are talking, because the Iraqi side is not studied very well. And most hydrocarbons that generated from Silurian are migrated downward, opposite to any other area. So it's accumulated in treble formation, treble sandstone. So same case should maybe applied in western part of Iraq. And in our area, we don't have any wells that penetrated Paleozoic rocks except Jabal Khan, so far, Jabal Khan, which drilled in early 1980s in Mosul area, and probably reached Harul formation. The sandstone unit from Risha well, which sandstone it's a good reservoir for gas there. And probably in Akkaz one well as well. Akkaz well, it's drilled in an area north, very close to Qaim town in the area. The traps are most likely is combined structural and stratigraphic in the region. So one more thing that making traps are horsed and graben in the western part of Iraq due to existing of a lot of faults. So I don't know how you remember horsed and graben. So two sides are going up and one going down. So like within a few kilometers are occurring and disappearing. So the people should be very, very careful when drilling in the area that it's reaching faults like graben and horst that making a really confusing situation for discovering oil. Within the Salman zone, the Silurian oil probably trapped within the Ga'ara formation. Like we have in Saudi Arabia, all petroleums are trapped in Khuf clastics. And Khuf, it's equivalent to Chazeri formation and equivalent to Ga'ara formation. So probably same formation, it's existing, but with different names. Triassic petroleum system, Triassic, it's coming after Permian and before Jurassic. So the main source rocks that related to this time frame, it's Qurashin, let we call in real word, Qurashin formation. The shell beds occur within the upper Triassic Qurashin formation. It's considered a good source rock based on studies of northeastern Syria and based on the interpreting or recognizing biomarkers within the oil in Butma 29. Butma, it's a well in western Tigris River, north of Mosul. The oil are aged, the oil source are source aged as a Triassic. So, and we can differentiate between Jurassic, the oils are which coming from Jurassic source rocks and from Triassic source rocks based on sulfur content. We can differentiate between them. Besides some like biomarkers which are identical for specific geologic age, like gamma serine, we can deal with it, or olenin, and the ratio between C28 styrene, C29 styrene, and so on. Source rocks, Triassic source rocks in Syria also recognized, and they named Amanos shell. but it doesn't have that much thickness amount formation. It's ranging between 19 to 50 meters, but with high total organic carbon, which is 3.9, almost 4%. And Orochine in that area, it's 15 to 40 meters thick, with TOC almost 3 weight percent, which is very good quantity of organic matter that existing throughout the Orochine formation. When in Rzgar area, or even in Tauke or Fishkhabur, in that area, Triassic source rocks are within the oil window, because from my study, I concluded that Jurassic source rocks are partially mature in a Tauke area. So if in Tauke area it's partially mature, so it means Triassic should be within the oil window in that area. So we have to look for Triassic oils instead of Jurassic oils in that area. And this is due to incomplete sediment overburden rocks over the source rocks. So in Mosul area, for example, the squares from Middle Sergalu until Aptian, which is like Sanwar formation, are missing. So these squares almost 400, 500 meters are missing. So this is affecting source rocks maturities level. And even in Arbil area, in Hawlel, like Guer, Zab, and we call Shamamuk area, or Zegora. Also, Jurassic, it's early mature. So not mature enough. In Sheikhan, we see the oils are very heavy due to maturity level. What's going on? In Salman zone,
Doctor, if that section is bothering you, please click on hide. It will be separate.
Okay.
Click on hide. Okay.
I just want to move it up and down. The Salman zone is almost totally within the oil window, while the Mesopotamian zone, it's within the gas window. So this is what we are talking about. It's Triassic source rocks. Triassic source rocks are within gas window in a Mesopotamian zone. But in eastern part of Mesopotamian basin, it's within it's over mature. In the foothill zone, it's different from location to location or from area to area. In high fault zone, it's within the oil window, but in foothill zones, it's within the gas window. The Triassic source rocks in foothill zone and Mesopotamian zone are reached peak oil generation during late Cretaceous. So around like 65 million years ago, 64 million years ago. In the Salman zone, oil generation in potential Triassic source rock peaked during the Neogene. So see how much different between two areas due to the geothermal gradient, due to the temperature that rising from mantle, from basement. Until now, just in Botma oil field, we have for sure Triassic oils. The others are not certain whether we have Triassic oil or no, but in some oil fields in eastern direction of Erbil, we have some gas in Benabawi oil field, which is located very close to Safin Mountain. As you see here, kerogen plots of Qurachain and Baluti formation. As you see, we have symbols for different samples that belong to different wells. And most of them are type 2 and 3 kerogens. And here, they are within the oil window, as you see here. And some others are not mature yet. Maturity level of Triassic source rocks here, as you see from foothill zone or western part of Tigris River, Salman zone, and down to Euphrates zone, we have mid to late mature, but the red color, as you see, are post-mature, and the yellow one is a gas zone. If we are looking for oil and gas in Iraq, we should consider the maturity level of source rocks, and then we start to drill wells according to source rock maturity stage. Reservoirs and seals that belong to Triassic time are Gallikhana and Qurachain. Qurachain, it's very thick formation that has different lithologies. It contains evaporite, it contains carbonate and shell. So by itself, it's a petroleum system sometimes. The Qurachain and Gallikhana contain oil in 7 oil fields of foothill zone. Besides, Qurachain produces oil in Butma oil field. Triassic reservoirs contain oil ranging in API, American Petroleum Institute, which is opposite to specific gravity. It's ranging from 28 to 45, averaging 34 API, which is considered a light crude oil. Sulfur content of Triassic oils are less than Jurassic source rocks or Jurassic oils, ranging from 0.04% to 1.5%, averaging 1.2%. But Jurassic probably sometimes reach 8%, 6%, due to, later I explain in detail, that's related to carbonate source rock. Jurassic oils are mostly originated from carbonate source rock, but Triassic are not originated totally from carbonate, probably originated from shale and marl. The reservoir properties of the Triassic reservoirs are different from area to area. That's related to dolomitization of carbonate, which in some cases increase permeability of the rocks. Triassic rocks are generally the anhydrite. This anhydrite, it's alternating with carbonate, so interbedded carbonate and evaporite makes a good seal rock for reservoirs to restrict oil from migration upward. Until now, most Triassic reservoirs linked to northwest of Iraq, like north of Mosul area until we get to Zaho area. But in South Iraq, still rarely the wells are penetrated Jurassic. Most of them stopped within Cretaceous rocks. Rarely they drilled more than 3,500 meters. Most of them are around 1,300 meters. So that's why we don't have enough information about Triassic reservoirs or Triassic source rocks in southern Iraq. The folded belt, like high folded zone and foothills zone, probably are prospective for the Triassic reservoirs. As you see from this picture or figure, that porosity in some layers are around 10%, or even more than 10% in some horizons. Within dolomitic increases. But when we have limestone, it's not brittle like dolomite. So the fractures are less than what we can get from dolomite rocks. But within the shell, you see, we don't. There is no any indicator for porosity due to shell doesn't have enough permeability and porosity. Probably has porosity, but because the pores are not linked together and they are not filled with liquids or fluids, that's why there is no any indicator for porosity amount within the shell unit.